Welcome. Today we are going to discuss depositional environments and how you can tell which depositional environment a sedimentary rock was deposited in. We will talk about the following topics: grain size, sorting, sedimentary structures, some typical depositional environments, and lastly, the lithification of sediments. The first thing you should observe when trying to identify a sedimentary rock is grain size. There are 6 major grain sizes. The first is boulders, which are anything larger than 1 centimeter across. The second is a pebble, that is from 4 millimeters to 1 centimeter in diameter. The next grain size is 2 to 4 millimeters. These 3 grain sizes are different than you typically think of when you colloquially say these terms. For example, gravel by this scale is much smaller than you might have if you have gravel dumped in your driveway. The next 3 grain sizes are considered small. They are sand, as seen on beaches and in deserts. Silt is smaller than sand, but feels gritty when rubbed between your fingertips. Clay is the smallest grain size and feels smooth when rubbed between your fingertips. This is an example of siltstone. These sediments are so small that they cannot be seen in the photo. Smaller grain sizes indicate that they have traveled further from their source and been broken down more by weathering processes. Smaller grain sizes also indicate that the depositional environment was calm. Calm environments include lakes and the deep ocean. The second trait to observe when identifying a sedimentary rock is sorting. A poorly sorted rock will have many different grain sizes in it. It usually contains some pebble-sized grains down to some sand-sized grains. A well-sorted rock generally has all of the same size grains in it. Quartz sandstone from a desert is usually very well sorted with only sand-sized grains. The further sediments have traveled from their source, the better sorted they will be. The third trait to observe is if there are any sedimentary structures. There are many sedimentary structures, but the most common ones are called beds. Beds are layers that were laid down either flat or on a hill. The flat layers are simply called beds. Those deposited on a hill, such as a dune on a beach or in a desert, are called crossbeds. A depositional environment is a location where sediments are being deposited or the process of sedimentation is occurring. Here is a diagram of some of the many depositional environments. There are lots of complex words on this diagram. I will explain some of the most important environments where sediments are deposited. The glacial depositional environment is dominated by glaciers and ice sheets. Glaciers dig up and carry all sizes of rocks, which they drop at the end of the glacier. Generally, these become breccia or conglomerate rocks that are rounded and poorly sorted. Lacustrine is a term for lakes. Lakes are very low energy and therefore generally deposit silt and clay in thin beds. These deposits generally become siltstone or shale. The Aeolian environment, shown in the bottom left, is an arid desert that is dominated by the wind for weathering and erosion. In deserts, usually the deposits are made of well-sorted sand and silt-sized sediments deposited in crossbeds. These deposits will become sandstones with crossbeds. Moving toward the coast, there are fluvial or stream environments. Fluvial environments are the most diverse and include every type of stream from creeks to large rivers. The types of sediments deposited in streams depend on the energy of the stream, with larger sediments deposited in higher energy streams. Deposits from rivers can become many types of rocks, but are generally dominated by conglomerates, arco-sandstone, or siltstone. At the end of streams, where they meet the ocean, the energy level decreases rapidly, forming a delta. A delta is a triangular-shaped fan of sediments that are deposited as the energy that was carrying them is lost. Deltaic deposits are generally poorly sorted sand and silt deposits that turn into sandstone or siltstone. Beaches are made of sands from deltas that have been moved to the rest of the coast. The sediment on beaches are made from shells of animals, sand, and silt that have been broken down and sorted by waves that are constantly coming into the coast. Beach deposits are cyclical. This is because sediment is deposited at every high tide every day in a repeated pattern. Beach deposits usually become quartz sandstone. Shallow oceans, such as reefs, lagoons, and the continental shelf, are dominated by sediments that are made mostly of animal shells. The animals pull calcium carbonate out of the water and create shells. When they die, the shells fall to the bottom and create limestone. The abyssal plain is another name for the deep ocean, which is a low-energy environment where clay and silt are deposited in thin beds. These deposits usually become shale. Those are most of the depositional environments on Earth. There are many more, but these are most of the major ones. The last process is lithification. This is the process that turns sediments into sedimentary rocks, which translates literally to rock creation. There are two parts to lithification: compaction and cementation. Compaction is the result of new sediment being piled on top and squeezing the water out of the sediments. Cementation is when minerals such as quartz or calcite flow through the sediments and stick them together. Lithification takes place over millions of years and needs the right conditions to occur. There you have it. Today we discussed depositional environments and how to tell which depositional environment a sedimentary rock was deposited in. Now, students will match 3 example rock types with their depositional environments.